Hello, this is Stephen McNutt from Densemode.com. In this video, we are going to configure Active Directory Certificate Services web enrollment, and then we are going to manually enroll a router using a terminal method. So let's go ahead and get started. Right now, we're looking at our RSA issuing certification authority that we created in an earlier video. If you don't have this done yet, I recommend going back and checking that out. You can find it in the list, either on the blog or on my YouTube channel. And once you've got that done, we're going to go here to this in Server Manager to this thing here. We have the yellow alert triangle. There's a link called Configure Active Directory Certificate Services, blah, blah, blah. So let's go in here. And as you can see, we've already configured the certification authority, and we installed the web enrollment and device enrollment earlier, and then now we have to configure them. We'll configure the network device enrollment service in the next video. This time, we're just going to do this guy. So we'll select him, select next, configure, and as you can see, it's pretty straightforward. So we'll say no. So let's see if we can't bring the enrollment GUI up here. And it's pretty straightforward. It should just be localhost cert srv. See if this comes up for us. And here we go. So this is all working. This looks pretty good. Okay, so now that's working, but before we can begin the process of enrolling a router, we need to create a template. So let's do that really fast. Under Server Manager Tools, you have this link here, Certification Authority, which opens the Certification Authority tool. And if you expand this, there's this folder called Certificate Templates. So we're going to right click on this guy, select Manage. That brings up the Certificate Templates Management tool. And we are going to take an existing default template and make a copy of it. We're going to use IPsec offline request. So let's duplicate template. And we're going to make a change or two here. So we're going to go over to extensions, and under application policies, we're going to add a couple things. Strictly, we don't need these for site-to-site VPN, but we may want to do some things with ICE later that would require the use of these additional items. So we're going to add those in. So we're going to add client authentication, and we're going to add server authentication. So these are our three application policies we have in our extensions field. So that all looks good. Let's go ahead and give it a name. We'll call it Densemode Router. Sounds pretty good to me. 2 years. Okay, cool. Okay, done. Then we just come back over to the Certification Authority, snap in, right click on this templates folder again, and select New Certificate Template to issue. And here we go. Densemode Router. Alright, so now it's there. Now we're going to set up the Certification Authority trust point on our router. So a trust point is essentially a container. It's not the best word because it doesn't really imply what it is, but that's what it is. It's just a container that holds the configuration for a specific CA, Certification Authority server. So we're going to create a trust point, and also we're beginning from scratch. So we're going to create RSA keys too. I want to show you the whole thing so you can relate the pieces together a little bit better later on. So one thing you'll definitely want to do before you begin the process of setting up a router for certificates is you want to configure the IP domain name. So let's make sure we have that done, which we've done. Okay, cool. Let's check and see if we have any keys already defined. So we can do show crypto key mypub key. If I can spell today. We'll just do all. And we have no keys. So this router has no keys on it. So it's a blank Etch-a-Sketch. let's go ahead and get started on that then. Go to your terminal, and we'll first make a key. Let's make an RSA key pair. Crypto key generating RSA. We'll do a 2048-bit key, modulus 2048. And now before I hit the enter button, I want to mention something, and that is if you do not select a label, by default it'll concatenate the host name with the domain name and use that for the key label just automatically. So if I just hit enter, it would create an RSA key pair called r1.densemode.com, which sounds pretty good to me. So we'll just go ahead and hit enter. I mean, if you want to, you could put in label. You could put in like label Bubba's key or whatever. But we're just going to go ahead and take the default like this. Done. And you can see right here it's telling us what it's going to call our key pair, right? And we can verify that by doing do show crypto key mypub key all. And now you'll see we now have a key called r1.densemode.com. It is an RSA key. We didn't really specify any of this, although you can. And this is if you were to count the bits, that's 2048 bits expressed in hexadecimal format. So there you go. Alright, so we've done that. Let's go ahead and make our trust point, and that's done with this command. It's crypto PKI trust point. Excuse my typing, it's late in the day. We'll call this Densemode CA. We'll call this one RSA. Okay. And we'll set the enrollment type to terminal. We'll configure a subject name, and this is like the format. You can look this up on the interwebs, but we're just going to do something real basic. cn equals r1.densemode.com. We'll call CO equals stands for organization. Densemode. We'll do an organizational unit. Why not? Equals IT. And that's pretty good. I'm happy with that. I don't think we really need anything else. This is also if you had labeled RSA keys, if you have multiple RSA keys. You can see right here, where is it? This is the command you would use if you have like a bunch of different keys on the router. This is the command you would use to tell it the router which key pair you wanted to use associate with your trust point. We're not going to worry about that. We're just going to use the default. And so we'll exit out. Now the next step is we need to authenticate the trust point. So we're going to crypto PKI authenticate, and then the name of the trust point. So that's going to be dm.ca-rsa. And now we hop back over to this page we have pulled up. We're going to select this download a CA certificate link. We want base 64. And we'll select download CA certificate. We're going to click save as so we can give it a meaningful name. We'll call it RSACA. Sounds good to me. Open folder, and then we can just open this with Notepad and paste it into the terminal like that. Done. Yes. And check out these the fingerprints. I'm just going to grab those and save those later just for fun. Alright, so we've done that. Now let's enroll. So let's do crypto PKI enroll. And then again, the name of our trust point, densemode.ca/RSA. No. Yes. Okay. So now we're going to grab this block of text. This is called a certificate signing request. And we're going to come back over here. We're going to go back to the the starting point, we're going to select request a certificate, advanced request, submit a certificate request using blah 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 blah. Click that one. Okay. Pop that blob of text in. And then the template, it's this guy here. And if you come and do this and you don't see the template you created, just a quick tip, it means that whatever account credentials you're using to bring this up doesn't have permissions. And where you go and fix that is you go back to the template console and you change the security settings for the certificate template, and you just add whatever you need to add there. But we're in God mode right now, so it doesn't matter. So we'll select Densemode router, and there's our template, and we'll click submit, and yay, we got a certificate. So we're going to select base64 encoded, download certificate, save as, we'll call it R1 basic, because we may come back and do something fancy later. Okay, save, folder, open with Notepad, grab the chunk, grab the blob of text, copy that, back to our terminal, and then the next thing we're going to do is crypto PKI import, and again we're going to do the CA, and then we need to tell it what the format is. Paste it in, done. And actually if you want to come back, we want to see what the options are. Just do that really fast. So these are your different options. So PKCS12, this would be if you, for example, had a router that you replaced and you're exporting the key pair. Like when we created our key pair, we didn't make the private key exportable, so we would be hosed if we lost the router. But in production, you might want to make the key exportable, you might not. It depends on your security policy. But that's what this is when you have, you're exporting the whole thing. It includes the public and the private key and all that. And it's in a file that's password protected. You can look it up on the internet to learn more about that. Okay, so we've done that. Now that we've done it, we've accomplished the task, let's take a look at a couple of things really quick. First, let's hop over to the RCA and go to the issued certificates folder. As you can see, I've been playing around a little bit, so there's some other things in here. But this was a certificate, this is the certificate we just issued right here. So we can actually open this up. Should let us open it up. Okay, while that's cooking in the background, we'll look at something else. Show crypto PKI certificate, I think, right? Yeah. Okay, cool. So we have two certificates in our trust on the router because we have the one trust point, and we have the CA certificate. This certificate was installed when we issued the crypto PKI trust point. What was it? It was the authenticate command. So when we issued the authenticate command, that was the process of bringing in the root certificate, or bringing in the CA for the CA certificate. And then the second certificate is the certificate that was installed on the router when we did the certificate resigning request, and then did the enroll command, and then we pasted the issued certificate back into the router, and that's what this guy is. So let's step through the fields. I'll just be really brief because you can always use the Google machine to dive deeper if you want. So what we can do is we can actually take a closer look by using the verbose command, which will actually show us more information in the certificate rather than just the summary. So we'll just step through this. So it's a version 3 certificate, which is pretty much what you're going to see these days. Again, you can look that up on the Google machine to see what features were added each time they came up with an improvement. The certificate serial number That's important from the perspective of revocation. For example, the CRIL is really just a list of revoked serial numbers. It kind of makes sense, right? Why would you have all this other stuff? All you really need is this. This serial number is no good. So that's what that's primary use is for. It's for revocation. And then this is just this is the type of usage for the certificate. Okay, this is the issuer. Here's our subject name. Remember when I configured the subject name under the trust point? So that was embedded in the certificate signing request and I'm sorry, this is the subject name of the certificate. I'm looking at the wrong certificate. Here we go. So this is the subject name of our. It was configured under the trust point, so all that was embedded in the CSR. So there's our common name, organizational unit, organization. And then this is what we configured on the, if you remember in a prior video, we configured our CDP, our CRIL distribution point, and we tested it, so we know that that works. You could paste that in a browser and it will work. This is the validity date. That's based on when we first configured the CA. And then this this is just what kind of algorithm we're using, which is RSA. And we're using a 2048-bit key because that's how we configured our certification authority when we built it up. This is the same thing. This was something we defined when we created the CA. These SHA fingerprints are used to uniquely identify the certificate. It's used in a number of different ways. What else do we care about? If you remember this guy, our AIA field that we configured. So we built up our OCSP in a prior video. So this is the payoff here. The router will actually use this. We're going to test this in another video down the road. And then if you remember just in our template just now, we configured some additional key usages, which was the client authentication and the server auth. The router's just showing us an OID here because it doesn't have the mapping like in the iOS code to tell you what the plain English name is for this. So kind of interesting. And then this just tells us the label, the RSA key pair that was used. So just super quick reminder. What happens is when you generate RSA keys, like with what I did earlier in the video, there's two keys that are cryptographically related. There's a private key and a public key. We hold the private key. The public key was in that certificate signing request that we sent to the certification authority. When the certification authority created the certificate, that public key is embedded in the certificate, right? That certificate is also signed with the public key of the certification authority, okay? And so now, another device that trusts that certification authority, right, it can use that, look in that certificate, it can get the public key that from this key pair, right? Since it's embedded in the certificate, it can get that public key from the certificate and use that to encrypt information or sign information or whatever and fire it across, and only this router can actually authenticate and or decrypt the information because it has the private key. This is the only device that can actually decrypt the data. So it's pretty cool how that all works. Anyway, I hope you enjoyed this and that it was helpful for you. Like, share, and subscribe, and I'll see you in the next video where we're going to configure the network device enrollment service. Have a good one.